Good evening. Today I'm going to explain the key generation in DS algorithm. As we have learned that DS is a symmetric approach where it uses the similar same key for encryption and the decryption on both sender and the receiver side, where it requires same key which converts the plain text into the cipher text. We all know the process of the we all know the process of the DS algorithm, where it contains 16 rounds and each round requires the key which is generated by the key generator. And today we are going to look into the algorithm which is required for the key generation, and I will going to explain about the first two key generations in this algorithm. And this is a feature structure, general feature structure of DS algorithm. And coming to the key generation block diagram, this is a key generation block diagram where we take the, for example, if we take the input as 10 bits, and next we have to we have to take that input into the p10 permutation, and then we have to divide it into equal parts where left side contain 5 bits and the right side contain 5 bits, and each part should be undergone once for the left shift where the single digits are moved to the right side. And we'll get a new 5 bits from here, and we'll get a new 5 bits from here, and when we combine it, and we'll send it to a compression permutation where 10 bits are converted into 8 bits, and this is our key 1, and this is our first key, permutating 10 digits into input 10 digits into another 10 digits. And then this is a transposition technique which we are using here, rearranging the elements according to the given permutation bits. And next we are splitting it, and then we are taking those 10 bits into the compression block, and we are coming out with p8 permitted rearranged elements where we'll get 8 bits. And this is the first key. For getting for the second key, we have to take the input from ls1 and ls1 of the left and right side, and we have to do the permutation, we have to do the left shift twice for this, so that we'll get. And after doing the left shift twice, we have to combine it, and we have to take it them into the 8-bit permutation transposition technique, so that we are converted 10 bits to 8 bits, and this generated 8 bits is a key, second key. So like this the process will be continued until the k 16 keys are generated. And this is a program which I'm going to explain to you all, is that we'll take a, for example, at first if we take 10 digit input as double one triple zero triple one double zero, it is a 10-bit input, and we are having with. And now our p10 rearrangement elements are 3 comma 5 2 7 4 1 0, sorry 1, it's 10 10 1 9 8 and 6. And we'll take input, and that is p8 also I will take now, and I'll explain it later. 6 3 7 4 8 5, it could be random keys or random numbers. This is a size of 10, but this is the size of 8. These are the permutations we are going to use for this input. Okay, so we have to rearrange rearrange this input. As I said that it is the it here it is a 10-bit key, and this is 10-bit key, and we are going to convert it into p10, where the p10 array elements are used here. So if the key what how we have to generate is that it is the input which we are using. So at the first position we have 3, and we need to check in this input, and we have to check in this input one first element, second element, third element. Okay, so in the place of 1 we have 3, so we have to check at that position what number we are having, that is going to be our output. Here in the input I have 0, and next in the fifth position the number we have is 1, 1 2 3 4 5. Okay, we are having 0. Next, again for the second position we are having 1, and for the next seventh we are having 1, and for fourth we are having 0, and then for 10th we are having 0, and then for first we are having 1, and for ninth position we are having with 0, and we have for eighth we have 1, and then for sixth we have 1. And this is the output after rearrangement of the numbers according to the p10, that is 00 11 00 10 11. And this output is going to split into two equal parts, and then we are going to do left shift once to each other part. So I'm dividing it, and I will place like 0 0 1 1. 0 is a left part, and 0 1 0 double 1 is a second part. After left shift, the output would be like 0 double 1 0 0. Each and every digit will shift its position to one left. So this second position will shift to 0, this one position will shift to second position, this second one will be position will shift to this one position, this 0 will be shifted to this fourth position, and the first position will be shifting to the last position. And we have to do the same with the right part of the output of the p10, and then we will result with 1 0 1 1 0. And this is the output where after this is the output where we have combined this is the output where we have done the left shift on the both the sides, and the resultant after combining it will get a 0 double 1 double 0 1 0 double 1 0 0 double 1 double 0 1 0 double 1 0. I have just combined this one and this one. That's it. Now for we are at this position where we are done with our left shift once, and we are going to send these 10 digits to the compression box, where 10 digits are converted into 8 digits with the help of this p8 elements. Okay, as we have done for the p10, we are going to do the same with these elements. Okay, and again we'll do uh, okay, but is out here the output after P8. We are going to now we are going to generate the output after the P8. Let's see here at the position 1 we have number 6. So check it what we have having in the sixth position in this input. 1 2 3 4 5 6, so we are having with 1, and at the third position we are having 1, and at the seventh position we are having 1, and the fourth position we are with 0, and at eighth 1, with fifth 0, 10 0, 9 1, and now we are obtained with 8 bits where our input is this, and now we are with this 8 bits output, that is double one. We're gonna cross check once. Sixth, yes. At the fourth position we are having, okay, and at it we are having 8, and 5 10 5 0 10 0 1, yes, we are okay. Now we are at this position, and this is nothing but our key one. This is our key one. We have to follow the same steps from first to last to generate key 2, but there is a difference where here we are doing the left shift only at once, but we have to generate a second key, we have to do the left shift twice on each part. So again we'll take the input, this one, and this is our input, okay. Now we have to divide this to equal parts. Double zero, double one, 0 will be the one part, and the second part will be 0 1 0 double 1. Sorry, we have to do the left shift for this obtained 10 digit number which is obtained at this stage. So our parts will be left and right divisions will be 0 double 1 double 0 will be the left part, and 1 0 double 1 0 will be the second part. Now we have to do the left shift twice on the both the sides. After doing the first left shift, the output would be like double 1 double 0 0. Sorry. And next, after second shift, after second left shift, we are going to get 1 double 0 0 1. Again for the right part, we are going to get 0. After first left shift, we are going to get 0 double 1 0 1, and after doing the second left shift for this, we are going to get double 1 0 1 0. We need to combine these two elements so that we'll get a 10 digit output. After combining, we'll get this is output, is out this output after ls ls2. This is the ls1, this is output of ls1, This is output of ls2. Now we need to combine this 1 0 0 0 1. Next double 1 0 1 0. Sorry. And this is our 10-bit digit, and we need to send these 10 bits which are obtained after ls2 to the compression box, that is a. Now this time we have to send these to same 8 8 digits compression box, and that is this. And okay, at the position 6 we are having, at the position 6 we are having uh, 1, and at 3 we are having 0, at 7 1, at 4 0, 8 1, sorry 0, at 5 1, at 10 0, at 9 1. And this is the 8 bit digit key. It is a second key. Actually this is a second key which we have generated, and and this is the generation of till this point it is a generation of the key 1, and from here it is a generation of the key 2. There is nothing difference in this both the processes, but where we are after the ls1 is a output which is obtained after doing the left shift only once, but where ls2 is the output which is obtained after doing the left shift twice on the both the parts, left and right parts. And now I am going to give a quick glance of this program, how this algorithm going to work from starting to ending. And this is the with all the requirements we need. And we are giving already we are giving p8 and a p10 inputs, and this is our input key, and it is sorry, this is our input array we need to read in the next step. And this is key 1, this is an array to store key 1, this is array to store key 2, and this is for swapping temporary array which will be useful for our next coming. And okay, now see, k1 and k2 are storing keys, and p8 and p10 are storing permutation keys. Now we have to enter a 10 bits. This is a line where we have to give our 10 inputs, that is this. From we need to compare this algorithm with this program so that it can be easily understood. Okay, after inputting the 10 bits we have applied the p10 array on the input. So this is the program way applying a p10, applying p10. It is a temporary number where we'll store the position of each p10s arrays. The will we will what it is, a cnt is a temporary variable which stores the numbers at each iterations of the numbers of the p10. And temp t is a temporary array which stores and which is useful for swapping of the numbers and rearranging of the numbers. And this code will explain you that. Suppose we are having see, first for I equal to 0, cnt is equal to p10 of 0. P10 of 0 we are having, p10 of 0 is 3. Okay, and next for that, and temp of I means temp of 0 is stored with input of 3 minus 1. Input of 2, we have to check whether input of 2 is input of 0, input of 1, input of 2 is 0. So like that we are going till the 10 iterations, so that we'll get a temporary array, which is to here this is a temporary array after getting output after getting p10. And next we are adding a null character to that temporary array. Now your p10 key is this. Okay, after we are printing the temp value for our comfort, for our verification whether we have done the rearrangements of the digits are properly or not. And then next we are going to this is a program performing the ls1. This is a program where we perform left shift for the first half, that is from 0 to fourth position in the array. And this is the code for performing the left shift onto the second half, that is from fifth position to the 10th position. Sorry, that is the sixth position to the 10th position. Whenever we are reaching to the end of the first part, then we are going to storing that last part with the first part that we have previously stored in this same is with this also. And the output after we are going to print this output after ls1 is that output after ls1 is this. We are generating this. And after doing that, we are left with p8 rearrangement. This is a here we will display the p8 key elements with this printf statement, and then we'll apply it same as p10 rearrangement we have to do for the p8 rearrangements. Then the finally the 8 bits which we have generated from p8 rearrangement is nothing but key 1. And now that is we are going to print here. We are going to print this. And I already said that the process of the k1 and k2 is same, but we have to apply the left shift twice instead of once. Generation of k2 will start from here. Same, we have to divide the both array 10 10 bits, and we have to apply the left shift twice on the both the sides. And this is the first time left shift onto the left part, and this is the second time this is the left shift to the left part. And this code is for left shift onto the right side at first time, and this is the second time that where we are going to do this left shift onto the right side second time. Now we are going to obtain a 10 digit number, and we have to rearrange that. This is a output here. After getting out of this loop, here the temp value is nothing but this one, where we are generated with output after ls2. This is output which is generated at that stage in this program. And now we have to rearrange the 10 bits to 8 with the help of the p8 array, and that rearrangement is done in this for loop. And now we are end up with 8 bits key, and that it is nothing but key 2. This Now we will just verify. Now we will verify with execution part of the code. This is all I already took this. And now this this is one which I have explained you before, and will just run. And we will give the input which we have given, that is 11000000. And this is the information, your p10 key. And output after p10 is this, and after output after ls1 left shift once, and this is the p8, this is a k1. And for performing k2 this is 1. And after that, after applying the after doing the left shift twice on the both the sides, and we are end up with this one. We'll just note down this number, we'll check whether we are done correct or not. 1010000101. Okay. And yes. Yes, 1 1 0 1 0 0 1 0 1. Yes, we got the same key, and that's it about the key generations in DS algorithm. Thank you all.